In figure, D and E are the points on the side BC of the triangle ABC, such that BD, this length, BD is equal to EC, this length, and AD is equal to AE. Okay, we have to show that triangle ABD is congruent to triangle ACE. Okay, guys. So this is a bit of shading for you guys to visualize. So those two triangles have to be proved to be congruent, right? How will we do this? So let us write the given first. BD is equal to CE and AD is equal to AE. I'll call this as statement A and this as statement B. We have to be making use of it, so why not write it off, right? So to prove triangle ABD is congruent to triangle ACE. And now the proof. Okay, so let's think about it. We already have two sides. With two sides, how can we prove that two triangles are congruent? Right, we have the list over here. With two sides, how can we prove that two triangles are congruent? Yes, it's either SAS if not SSS. So let's have a look at it. Can we use SAS? So for SAS, we have to prove that angle, this particular angle is equal to this particular angle. That will be your included angle, is it not? With respect to side, we have to prove that AB is equal to AC. So now you guys have to pause and think over which is more practical, proving these two angles or these two sides to be equal. Okay, I hope you guys are decided with this. See, with regarding to AB being equal to AC, we don't have any information which leads to that. But regarding to these two angles, we have something that we can make use of, and that is in triangle ADE. So using triangle ADE, we can prove that. So that's your clue. If you're not able to figure out that, we should be using SAS. So I'm telling the answer has to be with the help of SAS. Okay, so that is what I've decided, that we can go with SAS. So to prove that this angle, right, this angle that is needed, the included angle, to prove that these two are equal, we have to make use of triangle ADE. How can we make use of triangle ADE is the question to you guys. So what do you tell? What is the answer from your end? I hope you guys have tried. So the answer is this, angle ADE. This particular angle is equal to AEC. Angle AE, not C, sorry, D. These two angles. Okay, so these two angles are equal. Why? What is that? How is that possible? Well, it goes back to your basics of triangle. See, the triangle ADE is an isosceles triangle. Since two sides are equal, by default, the angles will also be equal. Because the sides are equal, right? The angles will be equal. See, statement B tells us the sides are equal. And we can tell that along with this, angles opposite to equal sides are equal. Make sense? Okay. So now with this information, how we can prove that these two sets of angles are equal? So let me begin with calling angle ADE to be equal to X. And this implies angle AED will also be equal to X. I'm calling them as X. Okay, I hope you guys are able to do the final part now. If not, you can unpause. Okay, I hope you guys tried. So angle ADB is equal to 180 degree minus X. Why is that? Can you think about it? The clue is somewhere over. Yeah, it's over here. Yes, angles on a straight line, linear pair. In this case, it's called as linear pair. So if not, angles on a straight line. Since they're talking about two angles, so linear pair. We can use this single word, this word. Okay, yes. So similarly, we have AEC, right? Will also be equal to 180 minus x. Agree? Since both are 180 minus x, 180 minus x. From above two equation, what can we conclude? Those two angles are equal. Therefore, angle ADE is equal to angle AEC, which are both equal to 180 minus x, right? And thus from AB, and we can call this as 1, from statement A, B and the equation 1, what can we conclude? We can conclude that triangle ABD is equal to, not equal to, congruent to triangle ACE by, with the help of SAS congruency criteria. Okay, with this help we can tell that these two triangles are congruent, right? And so you can see that things will be interlinked. So here we made use of the idea of isosceles triangle, we made use of linear pair. So things will be so, you need to learn to make use of all of this list. That's why I opened all of them. We'll be using different aspect, right, in different chapter. But yes, as a whole, you'll be getting question in your final exams. So just don't stick to one particular chapter, thinking that we just have to make use of this one, only this set of knowledge. No, maths is built on different topics, so the questions can be integrated.